Okay, so number 6 here we have a particularly tricky problem. First of all, this trinomial looks pretty brutal. We got a negative coefficient in our x squared term, on our quadratic term. The linear term is also fairly large, and so is our c term, our constant. I'm really going to hope that we can pull something out right at the beginning, factor out a common term. So if I take a look here, I definitely know I'm going to take out a negative at least to make this leading coefficient positive. Just makes factoring a whole heck of a lot easier. And it looks like everything's at least divisible by 2. Yeah, by 2. So I'm going to take out a negative 2 from everything. So I'm going to do that first. I'm going to factor out a negative 2 and then see what we have left. So if I take out a negative 2, I'm left with a 9x squared. If I take a negative 2 out of here, I'm left with a positive 9x. And if I take a negative from here, I'm left with a negative 10. All right, make sure you get that. If you take out a negative, I divide a positive by a negative, I'm left with a negative. All right, let's factor now. So that negative 2 stays where it is. Oh man, oh man, oh man. So now I'm left with, what times what makes 9x squared? Well, there's a couple ways to do that. Let me move myself down here. All right. So what times what makes 9x squared? Well, I'm going to take a look here. I'm going to say, well, all the ways to make 9. I'm going to use 3 and 3 first, and then try 9 and 1. So if this doesn't work, I'm going to try 9 and 1. All right. But first, let's try 3 and 3. So I could put the 3x here. All right, one reason to use pencil is I can then erase this. I can erase that if it doesn't work. So please use pencil when you're doing math, ladies and gentlemen. Just a good rule of thumb. All right, good life lesson there. And now I'm looking at all the ways to make 10. The combination of the outsides and the inside here has to subtract to make this 9x. They have to subtract to make the 9x. These are going to be opposite signs, so one of them is going to be a positive, one's going to be a negative. When positives and negatives interact, it's very much like subtraction. Right? They work against each other. So we're looking for two numbers that subtract to make 9x. So let's take a look here. All the ways to make 10. Well, I'm going to start with 5 and 2 and see if that works. Plug a 5 in here, plug a 2 in here. Do the outsides, 6x. And the inside's 15x. Will those subtract to make 9x? Yeah, that's not bad. Right on. Rock on. First try. Booyah, Grandma. Alright. So, now let's just figure out what signs need to go where. I want 9 positives left over. So I'm going to want the bigger one to be positive. So I'm going to want the 15x's to be positive. I'm going to want the 6x's to be negative. So the 6x's to be negative. Alright, so we've got our factor. This problem is now factored. So let's go ahead and actually solve. So let's go ahead and solve. Let's move myself back up here. So this is also tricky. I've got negative 2 times some number equals 0. So what do I know about when I'm multiplying numbers to equal 0? One of them has to be 0. So either this could be 0. How would I make this 0? Well, I don't know. Let me just set it equal to 0. 3x plus 5 equals 0. What if it did? What would x have to be? Well, I could minus 5 from both sides, take away 5 to get rid of that 5, and I'd have 3x equals negative 5. If I divide both sides by 3 now, I get x equals negative 5 thirds. That's what x could be to make this factor 0. And 0 times anything is 0. What about this over here? Well, what if 3x minus 2 equaled 0? If this whole factor equaled 0, that would work. All right. So I could add 2 to both sides. Add 2 to both sides, and you would get 3x equals 2. If I divided by 3, you would end up with x equals positive 2/3. And there, ladies and gentlemen, are the two solutions to our quadratic equation up above. Thank you, and see you soon.